Coming up next on Radio Control Hobbies, I'm going to show you how to tune your model engine. Hello everybody and welcome to Radio Control Hobbies. I'm Chris Chianelli and I love engines, all types of engines, from all-American big block stump pullers, high-revving imports, to the miniature engines we run in our models. But it wasn't always so. I didn't love the engine until I came to understand it. Success with the model engine is like flying. The more you understand about aerodynamics, the better pilot you can become. Well, it's the same with the model engine. On today's show, I have a special guest, a manufacturer of these engines who knows them inside and out. And we're going to show you how to break them in and tune them, both two-stroke and four-stroke. And we're also going to show you how to maintain them to get years and years of use out of them. Because some of them are expensive. After today's show, you and the model engine are going to be good friends. Here I am surrounded by all types of model airplane engines, and I love every one of them. I feel right at home. Let me show you a few types of engines we have here in the studio today. Over here, mounted in the Mariner from Lanier, is a Sato 72. It's a four-stroke engine. Notice the pushrod tubes and the valve covers. Four-stroke technology has really been improved over the years. They're getting smaller and more powerful while increasing the displacement. This is a Gold Knight. That's because it has the black and gold finish. It's also available in just aluminum for a few bucks less. But the Gold Knight, it's available for about $225, $230. Now, over here we have two very, very interesting, very special engines. Mounted in this Hobbyco Twin Star is two OS Wankels. And these things don't even have pistons. They have triangular shaped rotors which spin. And these little babies are available for about $230. Next, over here is probably my favorite. I just told you I love four-strokes and I also love radial engines, and this baby is both. This is a Sato, as you can see, once again it's a Gold Knight, a Sato 170 three-cylinder. And the thing I love about this, it's very, very scale-like on the outside and on the inside. It has internal components just like the big ones or the full-scale radial engines. Here's an example. This is the rod system on this engine, and you have a master rod and you have slave rods coming off of it, just like the big ones. This one sells for about $650, but it is a work of art. Now, over here, we have a very special little engine. It's a YS63, and what is so special about this little engine is that it's supercharged. YS makes supercharged engines in a lot of different sizes. And the result of the supercharging is you get lots and lots of power. The 63 can be bought for about $250. This is just a small sampling of the engines available. There's all types
Chris,
of...
you down here?
Hey, Randy. How you doing?
Good. How about yourself?
Randy Linsalato from MECOA K&B. Thanks for coming down, Randy.
Thanks for having me. Yeah, we've been in this business a long time.
Yeah, 20 years.
Yeah, or more.
What I like about Randy is he manufactures engines, but all types of engines. Four-stroke, two-stroke, racing engines, sport engines, helicopter engines. So
we get all the questions.
Randy's seen it all.
So hopefully today we can answer some of the most common questions I get.
That's right. When we come back, Randy and I are going to show you exactly how these little gems operate. Don't go away. Welcome back to Radio Control Hobbies. It's time to take a look inside Chris's DIY mailbag. Today's letter comes from Justin R. from St. Louis, Missouri. Chris, I run up my engine just before I fly. Everything seems fine. Halfway through the flight, the engine quits. I think I've checked everything. Could you please help? All right, Justin, have you checked the fuel line that's inside the tank? It's not uncommon for a little pinhole to develop on this line, and that's all it takes. One little pinhole, that's it. These engines are very, very sensitive to any air leaks. A good way to check this is run the engine with half a tank on the ground, and if you see any air bubbles, that's your problem. And the fix, of course, is replace the piece of tubing. To send your questions to Chris's mailbag, log on to DIYnetwork.com and search on Radio Control Hobbies. Since most of you will be starting with a two-stroke engine, Randy's going to demonstrate the induction process of a two-stroke engine.
Yeah, I brought her along a cutaway so you can see the internal parts of the engine.
So that's this engine, but cutaway.
Cutaway.
Okay.
And give me a hand here, Chris.
Okay, got it.
On a two-stroke engine, the carburetor, which mixes the fuel and the air, is located right above the crankshaft. And on the crankshaft, there's a valve that opens and closes. So as the piston travels up, the piston creates a vacuum in the crankcase.
Sucks in the fuel-air mixture.
Through the crankshaft. And then as the piston comes back down, the valve closes, compresses the fuel and the air in the crankcase, and the piston travels down further. It opens up the transfer ports in the sleeve, so the fuel and the air charger transferred into the cylinder in the combustion chamber. Now the piston comes back up again, and it's sucking in another charge of fuel and air, and it's also compressing the fuel and the air charge
It's in the combustion chamber, right.
Right. Then when it gets to the top, the fuel's ignited, piston's driven back down, and then the exhaust port opens up, the exhaust gases are expelled, and travels down a little bit further, the new intake charge comes in.
So the important thing to understand is there's always two things going on in a two-stroke engine. Up here you always have the combustion, and down here you always have the induction on every stroke. All right, over here we have this gorgeous OS 300 twin four-stroke engine. If you'll give me a hand
Sure.
there. The induction on a four-stroke goes like this. Here's the carburetor. The fuel and air is mixed right in here. And then it goes down into the intake manifold directly into the combustion chamber. It does not go through the crankcase. And as I turn the engine over, you can see the rocker arms. That's the intake rocker, which opens and closes the poppet valve. Poppet valves, exactly the same type that you have on your automobile.
You know, Chris, one of the most common questions I get is, what's an ABC engine?
Well, let's show them.
Well, let me show you what a ringed engine is first.
Okay.
This is the actual cylinder piston.
From this engine, right?
This engine right here. And here's the ring. And the ring is just like the one in your car, and it takes up the clearances between the piston and the cylinder.
Let me show them exactly where this is on this cutaway. See, that's the ring right there. And it keeps tension up against the cylinder to do exactly what Randy just said.
Now, an ABC engine doesn't have a ring. It has a aluminum piston, a brass liner, and a chrome wear surface inside, hence the A, B, C.
Okay.
And ABC engines, since they don't have a ring, they have a very tight fit between the piston and cylinder.
When cold.
When cold.
Like you can see that here on this diagram. This is exaggerated, of course, the taper. But the reason they do that is the piston and sleeve is actually fitted for when it gets up to running temperatures, right?
Exactly. The top of the cylinder is hotter than the bottom of the cylinder while it's running.
And the expansion rates of brass and aluminum are different, so they have to make it's tight at the top.
Exactly. That's the next most common question I get. My engine doesn't turn over. It feels like it has a tight spot at the top. And all ABC engines feel like that. When you turn the engine over without a glow plug in it, you'll feel a tight spot.
And because of that, there's a big difference between the way you break in an ABC engine
versus a ringed
engine.
Yeah, that's very true. You want to have an ABC engine always running at operating temperature. If you run it too cold, you don't get the right clearances.
You can wear it out if you run it too cold.
Wear it out.
Okay, Randy, let's talk next about carburetors.
Okay, to successfully tune your engine, you need to know how to adjust the carburetor and what the needle valves do. This is the high-speed mixture needle valve, which adjusts the fuel mixture at a high speed, and the low speed is always located on the opposite side, which you adjust with a screwdriver.
Okay, let me take the high-speed needle out and show everybody on this diagram exactly what we're talking about. All right, first, this is a cutaway of the carburetor, a side view. And right here is where the air gets drawn in, and it gets drawn past what we call the spray bar. And this is what lets fuel into the carburetor, and then it mixes with the air and goes on into the engine. Now, the needle that Randy was just talking about is shown here in an exploded view. As you screw the needle valve out, or counterclockwise, it pulls back this tapered needle. And as the tapered needle pulls back, it allows more fuel to mix with the air. And that would be called richening the mixture. Adding more fuel to the fuel-air mixture richens the mixture. The same principle is true for the low needle. Why don't you give a quick explanation on how the low needle changes as the throttle increases?
Well, if you can see in here, the low-speed needle comes in from the opposite side, and it works on the same taper principle. And Chris has a diagram in there. As the carburetor closes, the idle needle is moved into the end of the spray bar.
Show them on a full sweep the way, if you notice, this does not just move in a rotary fashion, but it also moves in and out. And that automatically meters the fuel. When an engine's at idle, it needs less fuel than it needs when it's at full throttle. And that meters the amount of fuel needed as you advance the throttle. And here's an example of the tapered idle mixture needle when the engine is at idle. See how it's in the spray bar? But then when you open it up, it pulls back and allows more fuel out of the spray bar.
We've really explained the basics, Chris, but once you understand the basics, tuning your engine can be a lot of fun.
Yeah, it's all about understanding. Okay, now don't go away, because when we come back, we're going to break in and tune and run some of these babies. For more information on tuning your model engine, go to our website, DIYnetwork.com. Stay with us. Welcome back to Radio Control Hobbies. We've moved outside to do some engine break-in. And if you want to do the same thing, all you'll need is a nice heavy-duty table and one of these engine test stands. This one's made out of machined metal, and it's available from a number of sources. Just go to your hobby shop. They can tell you where to get one. We have a 61, an engine available from MECOA, mounted, and we're ready to start it up. But before we do, there's two things I want to mention. Always have your eye protection, and make sure this procedure is done with adult supervision. It can be very dangerous. The prop spins at a very high speed. Do not let a child do this on his own. Okay, Randy,
Well,
take it
we're all
away.
set. I've got fuel in the tank. We have a fuel filter in the line here, and I've made sure that the idle mixture is on the rich setting side. A lot of times manufacturers say to back off a needle valve a certain amount of turns from where it stops.
Yeah.
This is our main needle. I want to make sure everything's running on the very rich side when I start it. That's why I have everything unscrewed and we're ready to start.
Now, when an engine's running, try never to stand in the plane of rotation. You could pick up a piece of dirt and it always throws off in the plane of rotation. So try to stand a little bit in front or a little bit behind. All right, fire
hook
up.
up my igniter here. It's a 1.5 volt battery to the glow plug. That's what gives us our ignition. And we have the throttle set at near idle
You always
position.
start at idle, right?
All the time, yeah.
Right.
Now we have our electric starter. See, now right now that's an indication that it's running
When you take the
way
glow
too
igniter
rich.
off, if it quits, it's probably too rich.
Also, if you look real close, you can see all the droplets of fuel coming out of the exhaust. That's another indication of being very, very rich. Now I'm going to make it go full throttle, and I'll show you a very rich setting. Now if you noticed, when I unscrewed the needle, the engine slowed down, and that's telling me it's a rich setting, because we're on the rich side of the setting. What we're looking for is the highest speed we can get with the needle valve. You never want to run an ABC engine at an extremely rich setting. That'll cause it to wear out prematurely.
Because it never reaches operating temperature.
Never makes it to operating temperature. Too much oil going through the system. That's very close to the proper setting. You see I went a little bit too far and it went too lean and the engine slowed down.
Would that be a proper setting for both ringed and an AB?
Ringed and an ABC, you're right in there. Now we know the idle mixture is way too rich because I couldn't get it to come up to speed very well. So I'm going to take and I'm going to turn my idle needle in a half of a turn, and then we're going to restart it.
When the engine's too rich at an idle like that,
it won't accelerate.
What happens is it probably puts out the glow plug and stalls.
Yeah, and you can't get a good acceleration. When it's set properly, you can open the throttle rapidly and it'll come
good
up
acceleration.
To yeah.
Okay.
And that's how you can fine tune your idle. So let's start it again. I turned it in a half a turn. Actually, you can see there's a little bit less droplets coming out of the exhaust.
Not as many droplets here.
When you accelerate from idle rapidly, and the engine hesitates like that, it's still running a little bit too rich.
All right, while we're stopped, there's one thing I want to explain. These engines, while yes, it's true, they're air-cooled, you also have to think of them as being liquid-cooled. All that extra fuel and oil you see coming out the exhaust, that carries an awful lot of heat out of the internal workings of the engine. So in a way, they're air-cooled and liquid-cooled.
Yeah, you can say that. Now we'll start it one more time here. Back to an idle setting. And now should be just a little bit rich at idle and a little bit rich at the top end. Engine's got just a little bit of hesitation when you accelerate, and you have plenty of oil coming out of the exhaust.
For step-by-step information on adjusting your engine, visit our website, DIYnetwork.com.
When you're done running the engine for the day, you always want to pull the fuel line off of the carburetor and run the engine dry at full throttle.
You don't want to leave any alcohol inside the engine.
Because the moisture in the alcohol will start rusting all the internal parts.
Yeah, the alcohol will draw moisture actually inside the engine and promote corrosion. Okay, now when we come back, we're going to fire up this big beauty right here. You're not going to want to miss this. Welcome back to Radio Control Hobbies. I promised you one monster of a motor, and here it is. Listen to this thing. does that sound full scale or what? Now this is a 4-stroke engine. You can see the rocker arms on the other side, but it has the exact same adjustments, the high needle and the low needle, just like on the engines Randy showed you earlier. It is a ringed engine, so you can run it very rich. To break in this engine, I'd run about 3 or 4 tanks. The first tank, I would not go over 4,000 RPMs. For tips on breaking in different types of engines, go to our website, DIYnetwork.com. They're living, breathing things to me. I love them. Randy, thanks for joining us.
Thanks for having me, Chris.
Because of you, a lot of guys are going to have a lot easier time out at the field with their engines.
I hope so.
I'm Chris Chianelli. We'll see you next time.